All right, hi everybody. Kubernetes SIG architecture for February 5th. We have one item on the agenda. Sergey brought it up, and we're going to discuss it a little bit here, but one of the key stakeholders in the discussion isn't here from Intel, Sasha. So we'll probably not spend much time on it, but just introduce the topic here, and then we may have to reschedule it for next time. I think the only thing is that I think Sergey was concerned about going to alpha with certain things. So this discussion will probably continue in Signode or we have a separate meeting actually for, is it every Monday or is it, no,
Yeah, we can find another forum. Yeah, let me just introduce the topic. Maybe get some early feedback from people on the call. You see my screen, right?
yes.
So there is a cap. This cap, DRA for native resources cap. Just a small overview of the land. There is a DRA plugin for native resources for CPUs specifically. So this DRA plugin today just expose every socket as a DRA like resource slice, and then you can claim those resources through DRA APIs, and this resource will be mounted to your port using some CPU sets. So there is like DRA plugin already exists, and then CAP is trying to solve the problem of how do we coordinate between pod spec and claim that was requested on a pod. So if pod is claiming 2 sockets of CPU, how does it coordinate with pod spec that may not have 2 CPUs in the pod spec declaration, or it may have it in different places, like pod level resources versus a container level resources. So like this coordination needs to happen, and that's why this cap was introduced. Just some brief overview. Like I posted screenshots here, but maybe easier to just share a screen like that. Some examples given in a cap is like very primitive example. One CPU is one. So it basically explains that one CPU is one CPU, saying like there is a device called CPU 0, and this device has native resource mapping of quantity 1. So it has this definition saying like if you claiming this device, you will be mapped to additional CPU in a quantity of 1. And then this is a very trivial case. And then another case is if you have a set of sockets, like let's say you have too many CPUs in a node, and you don't want to express every CPU as a separate resource slice because it's too expensive. Like you have too many resource slices, and you never schedule on individual CPUs. You schedule on like a bunch of them. So you may have a DRA plugin that exposes CPUs by bigger quantities, and then like quantity will be somewhere here. Like yeah, I don't remember how to read it. Yeah. Anyway,
Yeah.
Extreme capacity. So there's different ways to model the CPU, right? You could model the CPU as each individual core or pair of like hyperthreads is like an addressable individual CPU, and some of our clients like Slurm want to be able to have that level of control. And then there's other ways you can do it where we're like, well, we don't care so much about individual CPUs, but we care about socket, right? And so, or we care about like we don't care about individual cores, but we care about the actual CPU chip. So we say, okay, it's a CPU and it's got this many cores, or so it's kind of by socket. And then part of the reason we want to put this in DRA, one of the reasons is that it allows us to publish this metadata about, for example, it's this socket which is attached to this PCIe switch, which is attached to this memory controller. Like we can get really granular in understanding the details of the node, and then in the resource claim for these specialized workloads, they can say, okay, I need to have I need to have a CPU and a NIC that are both, you know, adjacent or directly connected to the same PCIe switch, right? Because I don't want data transiting across the cross socket um, the cross socket fabric, right, to transit out to the data center network. And so it allows this kind of alignment use case. So we have this already for GPUs and NICs, but if you don't align the CPU, your performance degrades. So this allows us to align the CPU. So that's one of the use cases. Another one of the use cases is a fungibility use case where it's like, hey, I this particular uh, pod could use a GPU, but GPUs are hard to come by. So if you can't get me the GPU I want, give me 40 CPUs, and I'll adjust my workload to run on 40 CPUs instead of on the
Yeah.
one GPU. And
So
then
yeah, and
the
this scenario is like
you do you want to continue, Sergey? You want me to give
yes,
another?
please. Yeah. So I want to short circuit it a little bit. So my biggest concern is not with this like uh, pools of resources, but also from associating device with specific quantity of native resources. So another scenario is when you have a device and this device is associated with some additional quantity of resources. So let's say you have a what is XPU, whatever thing, and then this XPU is associated with additional CPU and memory. You need to add to the pod if you want to consume it. So this is kind of when you consume, like again, in this example, you have an accelerator or whatever, like XPU thing, and this accelerator will add some extra resources for you to operate. And in case of CPU as a native resources, you consume a device, and this one like socket correspond to one CPU, and this one CPU will be added on top of what you have already defined. So you don't need to match what your pod spec and is and what is device defining. So those are kind of overview of what's happening. So now, what is the problem with it? Like, go ahead, Jordan.
I'm kind of trying to understand like what's the question for SIG architecture. Like there's a lot of details here that are particular to node stuff and scheduling stuff and DRA stuff. Is the question for this group like
I didn't get
how
to the question yet.
okay
So,
okay
yeah, introduction takes too much time in this because
okay
issues are quite complex. So like if you read the document, like questions like very bottom of this document that I posted in the agenda. Let me make it bigger. No. Okay. So I wanted to present some challenges with this approach in general. Like say, like I want a better solution, but I don't know what the solution layering supposed to be. The first problem that I see with this solution when devices have associated native resources is that devices, like native resources associated with the device is just a small fraction of what people may want for fungibility scenarios. So I can whenever we declared fungibility, like today, what we do is like all our inference workloads, like LLMD images, they carry drivers for every GPU they know about. And then whenever GPU is associated to them, they will pick which driver to use, which CUDA library to use. So it's like overhead that everybody carries just in case they will be assigned to different nodes. So ideally, like there are lots of conversations, how can we templatize it? Like how do we pick different images or override images based on which device we assign to? We also have examples when different init containers needs to execute on different environments. And specifically when you're talking about CPU versus GPU, I bet there is like, you're not only like amount of CPU request you have in a pod spec is just minimal set of changes you need to make to start to make your workload work on different hardware. So this first item is advocating to the fact that native resource is just a small piece of what you want to override in future, and API as it's presented here very limited to native resources and is not talking about other fields that can be overridden. So we need to potentially have a different solution, and having many different solutions for the same problem is not ideal. The second, I think advocating for complexity of this API. So API that is presented today is very associated with like this GPU requires that much, or this FPGA requires that much huge pages. But it doesn't tell much about whether huge pages needs to be associated with entire pod or with specific container. It tries to uh, tell what, like, try to introduce like per claim and per reference model, but this model is not very expressive. Like, let's say your container may have multiple clients to the same FPGA. Like, why wouldn't this be allowed? Why wouldn't we allow multiple buffers associated with a single container accessing FPGA from multiple processes? So this is not clear, not very descriptive, and it's very complex. Like you need to account for those extra devices in every piece of logic in kubelet. Like you need to account for it in place resize, in topology managers, in eviction logic. Like all the logic in kubelet needs to understand those native resources now and DRA, but DRA itself, like the API is not expressive enough. So on one hand, it's not expressive enough to cover all scenarios, but at the same time, like we introduce a lot of complexity just to cover those like a limited set of scenarios. And then third item is seems to be a big problem. We discussed with John yesterday how to address it. Like this claim-based resources buffer added to the pod. It's a first time we introduce by reference resources. So like in the past, pod spec is a source of truth, like how much resources we consume. Now, if you do by reference resource claims that define what extra resources this pod needs, it's the first time when pod is not self-contained, like pod spec is not self-contained. In order to schedule the pod, you need to have a pod spec as well as all the associated claims, and claims are not protected the same way as pod spec. So like pod spec is immutable in certain places, like you cannot resize it, but whereas pod resource claims may be resizable, and like you never know
if that's like true. I think pod could reference persistent volume claims, which could reference persistent volumes, which had scheduling implications.
I think scheduling is the wrong word here. Like the scheduling we're fine with, right? We know how to do this in scheduler. We already tracked down that, and it's today kubelet itself doesn't interpret claims at all. So kubelet just hands over identifiers for claims to drivers, and the drivers handle the claims. So where it gets tricky here is that because we're talking about native resources that kubelet has some responsibility for managing, we're spreading the management responsibility across these two things, which Praveen has thought about, right? And this is not new. I think Sergey's, the APIs are fairly complex, and so I think his concern is more around, even with the complexity, are we covering everything? And then if we're making, well, Praveen, can you say, like, how do you coordinate right now the kubelet side and the driver side of those allocations without this cap?
So I think like without this cap, it's pretty hacky in the sense that like whenever we are using the claim, we also need to duplicate those requests in the pod spec so that like scheduler and kubelet kind of understands what is happening in the claim without actually referencing it. I think the main intention of this cap was trying to avoid like this hack and make scheduler and kubelet know like natively what is being requested through the claim. We have discussed a little bit about like how this should be handled on the kubelet side, although I think like the main intention for not including in the cap now was to kind of limit the scope of it to like mostly the API changes and like discuss about like the node level enforcement things as a part of like Alpha 2.
So we're 20 minutes in. I'm still sort of waiting for the question for this group. But like again, there's lots of detail here, and there's lots of like node specific stuff. Have we gotten to the question
Yes.
for
Almost.
architecture? Okay. What's the question?
Let's skip this. So, my biggest like another small thing I wanted to introduce before good questions that sometimes fungibility needs to be done by on a level above the node. So like you need to do fungibility across multiple pods. Like if GPU is available, you need to like if 5 GPUs available, you schedule all 5 pods on this GPU type. If not, you need to schedule all 5 on different type of GPU. So fungibility that is implemented today per pod is not necessarily covering all the scenarios in future. So it's like extra note on layering of those concerns, like which claim to pick and which pod template will satisfy this claim. Anyway, so it all boils to this perspective I want to get from SIG architecture on what is the best roadmap for pod templatizing, like adjusting pod for specific device classes in future. So this cap is, I mean, maybe like storage has similar thing, but how I see it is like first time that we introduce a pod definition that is spread across multiple objects. Like pod definition defines some subset of resources, but then another subset of resources coming from claims. And then we may think of like other sources of information that will update those, tell node how to schedule pod. And I really want to, and like we want to teach scheduler and kubelet operate on those pod definitions that is dependent on multiple objects. What I want to suggest is if we have some kind of templatizer that updates the pod spec based on claims, then we can make it clearer layering-wise that node is operating on pod spec, which is self-contained, and it knows how to schedule which containers to run and how much resources needed for this container, while all the logic of picking which pod spec to execute is hidden in a logic that decide which DRA resource to use.
So I guess let me frame that a different way, Sergey, and correct me if I'm wrong, but like, we have implemented a resource claim fungibility. I don't think it's accurate to say this is the first time that the pod spec was perfectly self-contained before, because we already have resource claims, right? Like the difference is that now the resource claims in this cap are branching out into things that are also in the pod spec, as opposed to like, I mean, with extended resources, it was a little bit this way, but so I don't think it's fully contained. But I think the architectural question here is there's a limited scope of control when you make the fungibility at the resource claim level, because it's already like there's other things beyond just the resources that might need to change. So, for example, the most obvious one is the container image. If I choose GPU or I choose CPU, ideally I might need a different container image. Or for Google, we have GPUs and TPUs. I can do fungibility between them, but the hack I have to do now to manage that fungibility is I have 2 containers running and one of them goes to sleep, right? And so I think Sergey is saying, and I don't honestly think it's in conflict with this cap. I think it's a different scope than this cap and a different project than this cap. But like what Sergey is saying is, hey, how much complexity do we want to introduce here where the scope of control is limited, right? It's just a single resource claim for a single pod, when ultimately we might want something that looks more broadly, looks not only at one pod, but multiple pods, looks not only and looks at available devices and kind of makes a selection across those pods, and then potentially delivers a different pod spec based upon that choice. And I think that would be a better solution. I just think that, and my comment on here is like some of this is art of the possible. Like how much can we achieve with our existing infrastructure? And my other, so I'll stop there, Sergey, if you have any comment before I continue.
Yeah, David has a
Do you mind? I want to try to make sure I'm understanding. This has been probably the longest intro to a question ever.
Sorry.
Trying to think what I'm understanding is that logically we have a thing that right now looks like a pod spec. But logically we want to have something that's like most of a pod spec, and then we want to have this other resource that we have, and we want a scheduler to then use those two pieces of information plus the current state of all the nodes to make the best scheduling decision possible, to then produce a pod with a pod spec that would actually run at the destination. So the thing choosing the shape of this pod is actually the scheduler based on what
availability of hardware. Yeah. So there's actually a super interesting, Sergey, and I mean, this was kind of, I don't know if this was the right forum to bring this to, but Sergey, there's another discussion we should talk to Pavel. Like there's going to be the workload aware scheduling meeting. Sorry, David, did you have more to say? I kind of cut you off.
I wanted to be sure that I understood all those pieces, because then I was thinking about like, hey, it sounds like you just want a different construct to actually know about n things, produce a pod that is then just assigned to a node. Or call it a scheduler, right? But like given primitives today, that seems like what I would do if I understood the problem correctly.
Yeah, that's exactly the problem. I really want to avoid complexity, like death by thousand cuts when pod spec, like Kubelet needs to know about pod spec, but now it needs to know about resources coming from this type of claims, and resources like in future someone else will add a little bit of it, like maybe image will come from different place, and then conditionally we'll run containers based on third thing, and it's all goes to Kubelet as a set of external flux and conditions, and then Kubelet decides what to run. Instead, I want something else to decide what to run and give Kubelet the thing. And I'm looking for this templatizer to be implemented. And if we have a templatizer, I don't want this cap. If we will never have templatizer, then cap is probably one way to go. And then we need to discuss like how to not to die in complexity.
Yeah, well, I mean, we might be able to simplify this cap, but like what you're talking about, I think templatizer is one solution, but the work going on in SIG scheduling and SIG auto scaling and right around converged auto scaler, like those are still about the workload spec is the workload spec is the workload spec. Like they don't alter it. What the DRA prioritized list stuff does is offer some optionality inside the claim, and one like Q has a similar problem where they look if they were to look at the prioritized list of a resource claim, they don't know how to do accounting for the quota, for example. So what I've suggested to them is that they don't. Instead, what they do is they operate on top. So what they can do is they've got a viewpoint that the scheduler, the dynamic resource plugin doesn't have, which is a pod by pod viewpoint. Q has a global viewpoint. So they can actually look at that resource claim and they can say, you know what? I see that the workload author is expressing their intent that there's some fungibility here. There's some optionality here. I know that we have a whole bunch of GPUs available, and that's their first choice. So I am going to quote off all those GPUs for them, and I'm going to rewrite their spec and get rid of the other options so that I don't leave it up to the scheduler to decide later. So the resource claim prioritized list, which we already have regardless of this cap, gives the scheduler optionality. And what you're saying, Sergey, that I hear is that that's not always enough. And I agree. And that there are other places we might have to add optionality. This still may serve as a signal, like one of the signals, but like,
I guess I would say if you're talking about rewriting your pod spec based on which devices you get, they're not really fungible. Like that to me, it's a signal that you actually have two. If you want to run different images with different options, with different args, with different things, you have two deployments. You have a GPU-based deployment, and you have a TPU or a CPU-based deployment, and you need a higher level earlier in the pipeline to look at what's available and decide what's available and decide what you're going to scale up or reserve or whatever, and which of those things you're going to like activate.
So you're right for certain types of jobs. So the fungibility is useful is in auto scaled jobs. So this is a subset of the use cases. Like you're never going to use it in training, right? It's not
right. But if you're having to like rewrite your pod spec to run different containers to do different things, it's not the devices aren't fungible anymore. Like they're specific and you're reacting very differently to them. Like if you bake that logic into one container image, that's like, if I get GPUs, I can do this thing. If I get CPUs, I can do that thing, and it can handle either. Then the devices are actually fungible,
right?
And it's fine.
And this is about how you build your workload, right? Like you can build a workload that's fungible. You can build one that's not,
right?
And so,
I guess I'm like supporting fungibility for workloads that can react nicely to either seems fine. Requiring a GPU flavored one and a TPU flavored one and a CPU flavored one when the workload is going to have to do something totally different also seems fine. I'm struggling to understand sort of trying to merge the two, where we say we want this late binding dynamic decision thing, but also we want to, like at a late stage, totally rewrite the pod or workload or like.
I think the solution for I see what you're going. And the solution, we do have a solution as a community for the ones where it's totally different, and that's like the inference gateway. Right, so you take different node pools or different like groupings of completely different workloads, but that answer the same questions, that respond to the same API, and may have different characteristics in their cost and latency and things like that. And you schedule your requests across those. So we kind of do have a solution for that. The prioritized list piece is solving a similar problem in a more limited scope at a different layer of the stack. And so I think the question maybe Sergey has is like, what's the complexity budget for solving it at that layer versus the other layer? And I mean, we have, so is that accurate, Sergey?
Yes. I feel like this layer of fungibility may not work. Like if we solving fungibility on this layer, I want way more templatizing ability than what you provide with native resources.
It sounds like there were two sort of topics. One was like changing the shape of the pod spec in response to the late dynamic decisions, like the templatizing piece. And the other piece was, how does the kubelet know what CPU and memory to apply to the containers it's setting up? Not changing the shape of the container specs at all, but just saying like the kubelet's setting up C groups for these things. If the DRA pieces are expected to influence the C group memory CPU stuff it sets up, how does the kubelet do that? Are we planning to teach the kubelet about that? Are those two sort of independent questions?
So if we allow, like if we have a layer of templatizing that will just give node whatever needs to run as a pod spec, then we don't need to teach kubelet anything. However, if we say there is never will be this layer, we may need to teach Kubernetes small things, and these conditional things will be like, my worry is that those conditional flags will be everywhere, and Kubernetes will have too many things to check for before it runs the pod, and maybe a little too expensive. So ideally, I want Kubernetes to operate with a pod spec that is contained, rather than teaching Kubernetes with every single trick of this layer of fungibility.
I'm not clear that that's what we're trying to do. Like, we already have crossed the bridge of, right, like, there's some fungibility or by reference things through resource claims. Kubelet doesn't actually have to know about them, I guess, is the bridge we haven't crossed. And when you layer in native resources, potentially Kubelet has to know about them.
So the templatizing is not unbounded. It's basically fiddling with the CPU and memory.
Well, that's one option we talked about, was like you could actually use the resize API to like end up with something in the status. But yeah, David, I think that's Sergey's point. That won't be the end of it. Yeah. But I would argue that this isn't a solution for all things to all people, right? So, but also, and I see your hand, Praveen, sorry, like, we're just talking about the fungibility here, but like there's other use cases around this as well. So it's a little bit, and we don't have Sasha here to represent on those specific device use cases.
Just from an architectural perspective, knowing what the canonical representation of CPU and memory consumption is seems important. Like for all of the actors, scheduler and kubelet and quota and I don't know what else. Like all the things that say like how much of these resources is being consumed. It seems like as a project, we should have a coherent answer to that. And if we're saying previously it was just quantity of CPU and quantity of memory, and that is not sufficient, we need something like DRA's counter sets. Like you can slice it 11 different ways. Like maybe that becomes the answer. And like, yep, you have to represent it this way. And you need to define how those just quantity measurements inside pods translate into the counter set world. That could be okay, but we need to have an answer to how do you understand consumption so that all the different components can do that coherently. And maybe that means teaching kubelet how to read that and understand that. But kind of saying, oh, we're going to do it both ways and those interact, but depending on which component you are, like just look at pods or just look at DRA or look at both of them and try to wrangle how they combine component by component. I know we're wanting to defer some of those questions, but if we're opening the door in this KEP, it seems like saying what is the way we say how much CPU is being used in the cluster is important to be able to answer.
Yeah, so I just had a comment about like the complexity on the kubelet side. Like I agree that like we are introducing one more way or like one more variable that kubelet needs to look at like to configure like C group settings. But in terms of like implementation complexity, the way I'm thinking is like it's kind of similar to what we did when we introduced like pod level resources, right? Like earlier we only had requests specified in the container spec. When we added pod level resources, we had to look at like both the places to kind of figure out like for that, for like while setting the C group, how do we set it based on these two things. And with this kept, like the current proposal is kubelet need not go and look at like all of the resource claims. So basically the scheduler allocation is kind of added to the pod status. So kubelet needs to look at like container spec, pod level resources, and like this new thing in pod status to kind of figure out the C group thing. It is complicated. I'm not like saying it's not, but the changes itself would be similar to or along the same lines as pod level resources.
Yeah. If the expectation is that the DRA bits boil down to a quantity, the DRA bits that the kubelet has to pay attention to boil down to a quantity recorded in the pod, even in pod status. That seems containable.
Yeah, that is the plan right now, I believe.
Yeah.
So we talked about it could be useful. I don't know, but like the resize sub resource actually changes the spec, not just the status. So we might want to look at whether that single way of doing it, but I think there would end up being two code paths there that like it's a different operation. It would be done pre binding, I think. So it's a little bit weird. Like we'd have to think about it.
I guess like again, I'm trying to keep the discussion here like architectural focus. Having a clear data flow, making sure it's ordered. The thing that I see us doing is like having these circular data flows where there's no real source of truth, and it's like, oh well, we can't decide X until Y, and then after we decide Y, that changes X, and then we have to redecide. Like that's the kind of really tangled flows. And so basically a graph of like what are the changes, what's the order they happen in, what are the decisions, and making sure that only flows in one direction. That's the kind of thing I'm hoping. Yeah, directed graph. That's what I'm looking for in general for discussions like this, and making sure we actually draw that graph, because we talk in words and people hear different things and they think they're in agreement, and then we actually draw the graph and try to implement it, and we're like, oh no, I thought this late binding thing could actually change the input to this earlier thing. And so like put directed graphs in designs and make sure they match the implementations. That's my best advice for untangling this.
Okay, it was more extensive discussion probably than we intended, but I think that's I find that helpful. What do you think, Sergey? Maybe it doesn't give you the answer you want right now, but it seems like a direction. What do you think?
I think if you boil down to whatever scheduler does with binding claims and like reading the DRA like claim native resources and putting them back into pod spec, that will be like, that's exactly what I want. Like I want this templatizer that puts everything back to pod spec and then kubelet knows what to run. I don't want to get in a situation when kubelet needs to be versioning which DRA claims it can read and it cannot read, and then decide based on those unknown.
Maybe templatize is a weird word. Like progressive refinement of status. Like if there's an order of operations, like the pod comes in here and then the scheduler takes a crack at it, and then some DRA controller thing takes a crack at it, and like gradually stuff gets recorded into status. That seems very plausible to me, and we can write rules around like these transitions are allowed, and once you set this, it can't be unset, or it can only increase or can only decrease. Like we worked through a lot of these things with the resizing, resource resizing flow. That feels a lot more contained than like templatizing. So templatizing, like we're going to change the shape of the pod entirely and run different container images with different args and like that.
Well, that's totally circular, because like
right.
The resource claim is contained in this pod spec, right? So you can't.
But like a directed series of steps where we are, the scheduler agrees, and then this gets resolved, and then this gets summed up into this much CPU and this much memory that the kubelet should put in the C group. Like, and record that in status, and the kubelet looks at this one field to set up its C groups. Like that, I can imagine that working.
Yeah, I think that is the current proposal. Like the scheduler is it looks at everything, takes the decision, records it in status, and that would be the source of truth for all the downstream like basically kubelet looks at that status. It does not take like independent decisions again based on like looking at claims and deciding. So I think that's the
Maybe that wasn't as
state.
clear in the cap as it needs to be, Praveen. Maybe we need to
Okay,
make.
maybe yeah. I can take another look and make sure that is like more obvious on the cap.
And it's helpful to list out the things we know of that pay attention to CPU and what they're looking at and what they use that information for, whether it's quota or scheduling or kubelet, setting up C groups or auto scaling, like listing the things we know of and where they're looking for this information today and whether they would have to change or not and how they would change. That's super concrete and super helpful. And we will actually have to either do that work or describe that work for
Eventually.
these various types of consumers.
So what is the significance of pod status versus pod spec? Is there any reason why we don't do pod spec update as we do in resize?
Usually it's
my
user
prob-
versus
Usually
not.
spec is user. So like a resize is a user initiated action, whereas a choice made by the scheduler is a system action.
Yeah. So like node name living only in spec, I think was probably a mistake. Like maybe the user being able to request a node name in spec, but I think when the scheduler binds to a particular node, I think that probably should have gone in status.
Yeah.
So we could distinguish between like a user request of a node and the system acking that request. So things in spec come from the user or the controller that created the pod, and things in status come from the system acknowledging or agreeing with or processing that.
And status may have an effective value, whereas spec may have a requested value, right?
Mm-hmm.
Yeah, so we need to teach all the limit rangers, so like quota calculations, everything to look at pod status now and trust the pod status instead of spec.
I think the good part is like all of these components that look at like pod resource footprint, it only looks at this library called node request or something. So we need not teach these like individual components. So if we make sure the library is updated correctly to look at like pod spec and status, like all of these consumers will automatically like calculate the right value for pod footprint.
Once they
Recently, by the way, for sidecar.
switch from directly reading the API today to using this new library and update to use the current version of the library as we change it in the future.
Yeah.
Both of those are non-trivial assumptions. Yeah.
I mean, we can continue in a cap trying to discuss which specific fields and how to protect those fields to not be abused. How do we ensure that only DRA controller can set those overrides for pods, for containers, container requests, container limits, pod requests, and pod limits? Yeah, if we can, we probably need to decide on that.
I mean, I think I don't think we do that for everything else in pod status, right? Like control, generally users don't have the ability to write to the status, and I mean, not ordinary users, and the controllers, anybody could hammer anything across any of our statuses, and generally we don't have that field level access control. It's a sub-resource, so there's sub-resource level access control, but individual fields, we don't have access controls.
Yeah, I'm still super uneasy with that. Like, I still feel it may be much better if pod spec is different for different resource classes, like, and the way how it's mounted. I don't know.
The spec is writable it's immutable once it's anyway. Okay, we can continue with that discussion later. I think that covers it. Shall we? Any other questions, or shall we finish up? Abhishek.
Hello, this is my first time here. So I'm working for Meta, and we're trying to build our own Kubernetes systems. This is the first time the company is initiating a Kubernetes offering, and we plan to keep it internal for now. My question was regarding the conformance tests. Can we submit our conformance test for the cluster and get a conformance logo, even if our plans are to keep this offering internal for the moment? And I'm sorry if I'm asking this as the wrong forum, but yeah,
Well,
I'm happy to
not a
hear.
bad for it. I think that decision would be with the CNCF. Like we define the tests, but I think that the rules right now say that like somebody else has to be able to run it. But I mean, if it's not public, I'm not sure the value of publishing that it's conformant when unless you're like going to offer it to other people. I can put you in touch with the right people at the CNCF to maybe have that discussion. They like the actual rules are theirs. Ours are that we define the tests and say, okay, these tests, if you pass all these tests, then you'd be considered conformant as far as we're concerned. But the CNCF controls the program that like gives out the official thing. But if you reach out to me after on Slack or something, I can try and connect you to the right people.
Okay. Thanks. Appreciate it.
Yeah.
I linked to the actual terms, and like I think the phrase John is referring to, it's called end user reproducibility, which
Yeah.
if it's an internal only offering, like your end users, the point is anyone who's using your platform should be able to follow the same instructions to show that it passed the tests. So if it's an internal only offering, like I guess your end users are internal only users, they could follow the instructions themselves. It's a little
not reproducible by anybody in the world, but
it's reproducible by everyone who can use your offering, which is only,
right.
I guess, you. So I guess I would have the same question about John, like official conformance, like what's the benefit? Like in terms of being consistent, running the tests and making sure that they pass is great. Like that sounds good.
Yeah.
But getting an official stamp of approval, like who is that for? Versus like an internal, yep, we can pass this test and it's green. That's good for us to know. So.
Yeah. Cool. Thanks. Yeah, thank you. Let me think about some of these questions. I don't have answers to many of them, but I'll ping you offline.
Okay.
Thanks.
Okay. All right. Thank you, everybody. See you next time.